Yeah, welcome back, guys. Welcome to today's tutorial. We're going to continue on our topic, simple equation. And what we are going to be looking at today is solving simple equation by collecting terms. Now, in the first lesson, I explained what simple equation is, and that because we have introduced the equal to sign into a algebraic sentence, then it has been transformed to a simple equation. Now, I want to go further to see what we mean by collecting terms, and please do follow me as we go on in this topic. Now, the concept of collecting terms is about grouping all like terms, and I've explained earlier that in a simple equation we have what we call the alphanumeric, or we have the numeric numbers. Now, and I call the alphanumeric, I told you that they are unknown. So when you see alphanumeric numbers, they are unknown. When you see numbers, that's the the numbers or the numerals, any way you choose to call them, they are called the constant. Now, so you can see that the unknown terms on one side and the constant on the other side. Now I told you that there's the right hand side, there's the left hand side. So whichever way you think your arrangement will work, you can group either the unknown and on one side, either the left or the right, and your constant on one particular side. That's the concept of collecting terms. It means that whatever looks alike should be on one side and the other should be on the other side for you to be able to get your work done on time. Now let's look at this example I give you now. Look at this equation now. This is 8x minus 6 equals to 3x plus 9. Now, you can see I've highlighted here that 8x and 3x are the unknown. So any expression that carries a letter with it is basically unknown. Reason because you can assign any value to the letters, and as long as they are not standing alone, as long as they have varying letters, they are unknown. But we see here we have minus 6 and 9 are the constants. So when numbers stand on their own, this cannot be altered in this expression. Nothing can change 9, nothing can change minus 6 in this expression. So we call those ones constants. Now let's look at some examples on how we can apply what I've just said, and let's move forward. Now, we have two examples before us now. This is 8x minus 6 is equal to 3x plus 9. And we have 5x minus 17 equals to 2x plus 10. So now we're introducing ourselves to the importance of collecting like terms. Let's look at the first example. Let's solve. Now we have 8x minus 6 equals to 3x plus 9. Now, collecting like terms, like we said earlier, let's bring this to this side and let's bring minus 6 back to this side. So we have 8x minus 3x equals to 9 plus 6. You recall from the previous lesson, I told you that the sign before a number are both attached. So the negative you see before the 6 here goes with it. So when this 6 moves, it's as if you are changing the negative to positive when it crosses the equals to sign. The same thing for the 3x here. This is a positive 3x, but when it crosses to this other side, it becomes a negative 3x, as you can see from here now. That's why we have 8x minus 3x equals to 9 plus 6. So these are like terms. These are like terms. Now let's perform the various operations we find in between them. So this is 8x minus 3x, and that is going to be 5x. And 9 plus 6 is 15. So I write 15. Now, we've said that we want to assign a value to our unknown. And I said in the first class that whatever value is beside this unknown is what you use to divide both sides. So since we have 5x here now, I'm going to divide this both sides by 5. So 5 cancel this 5, and 5 and 15 is 3 times. This is 1, this is 1. 5 will go 1. So I'm left with x equals to 3. I hope you've learned that now. Now let's look at another example as we move forward. Now this is 5x minus 17 equals to 2x plus 10. Now the same way I did, let me bring my unknown to the left hand side. Let me take my constant to the right hand side. So I have here 5x minus 17 equals to 2x plus 10. So bringing my unknown to the left hand side, so I have 5x minus 2x. You can see it's a positive 2x, it becomes negative. Then I have 10. This is a negative 17. When it crosses, it becomes a positive 17. This is plus 17. Now, so I perform the various operations. So 5x minus 2x is 3x equals to 10 plus 17 is 27. So, like we said earlier, you divide both sides by 3. Whatever number is beside your unknown is what you use to divide. I'll keep reiterating that. Now let's cancel out this. 3 cancel out 3 here. 3 here 1. 3 in 27 is 9. So x equals to 9. We have come to the end of today's lesson. You'll find link to an exercise to complete for what we have learned in this module. So I look forward to receiving your feedbacks, your answers. So do well to submit them on time. Thank you.